So now the question says we have this equation x cubed plus x over 2 minus 8 that is equal to 0. And in its, it says it has one real root which is denoted by alpha. Okay, so there is one root that is alpha. It says find by calculation the pair of consecutive integers between which alpha lies. So what does this mean, between which alpha lies, the pair of integers? Mhm.
सर यानी हम हिट एंड ट्रायल करेंगे.
Yeah, you will do that hidden trial and you will see that like now this has to be consecutive integers. So I'll just be trying the positive integers here, okay? It says 1 plus 1 over 2 minus 8. So this is a negative value here. Then I'll try f of 2. That is 8 plus half. Oh, this was such a Sharif question here. So this is a positive value. So you see that there is a change of the signs. F of 1 is negative and f of 2 is positive. So that means this alpha definitely lies between 1 and 2. You got it, people? He was saying that find the pair of consecutive integers between which alpha lies. So alpha lies between this 1 and 2. You only have to show the change of sign here between these trials here. Okay. And then it says show that if a sequence of values given by this iterative formula, now the iterative formula is x raised to power n plus 1, that is 8 over x n minus half. Now, the second part, show that if a sequence of values given by the iterative formula, this converges, then it converges to alpha. Like it says that this iterative formula gives us the value of alpha. So how can we show that this will give us alpha? Any idea? How to show that this iterative formula is going to give the root of this equation, which is alpha? Yes? Basically, you have to show that this equation is same as this equation. Like if you remove these symbols, like if you just write this as x, that is equal to square root of 8 over x minus half. Let me read this question again so that you people understand. It says, show that if a sequence of values given by the iterative formula, this converges, then it converges to alpha. Okay. Obviously, when you apply the iterative formula, when you start that iteration, you get a sequence of values. And then you see that when it converges, so that is your root there. That is the solution here, okay? So we have to show that this iterative formula is going to give us the root of this equation, which is alpha. So that means we have to show that by removing these symbols here that these two equations are same, okay? So I'll be squaring both the sides. This is x squared. It's 8 over x minus half. And I take the LCM here, which is going to be 2x. And this is 16 minus x. Okay. Oh, I think there was no need to do that. I think that is required. Okay. I do that cross multiplication. I have 2x cubed, that is equal to 16 minus x. Okay. And then you see that he has divided both the sides by 2. This is x cubed, that is equal to 8 minus x over 2. And then we bring all of them to the left-hand side. So this is x cubed plus x over 2 minus 8. You see, we get the same equation. So we have shown that this iterative formula is going to give the solution, the root of this equation. Okay. And then it says use this iterative formula to determine alpha correct to 1 decimal place. Give the result of each iteration to 4 decimal places. Okay, I'll try to create some space here for this. So I'm just going to erase this. Okay, I'm just keeping that alpha is between 1 and 2. Okay, Let me write this here and then I'll erase this. So we know that alpha is between 1 and 2. I'll be using this. Why I'm keeping this alpha is between 1 and 2? Hmm? Any idea why I've written this at the top?
Sir, because
Sir, आप give
we know
X.
that's where the root is.
I couldn't hear you guys. Can you please repeat that? What did you say?
Sir,
Sir,
because
you
we
would be
know
putting
that
the
our
values. Sorry.
Two people speaking at the same time.
it's okay, go ahead.
Yes, please quickly tell me. Yeah, Mariam, what did you say?
Sir, because we found out that the root is between 1 and 2.
So what? Why do
So
I?
we're using values.
That will give me the initial value basically. Like I know that I have to keep the initial value as 1 because the root is between 1 and 2. So whenever you have to do this iteration, you always need an initial value. Okay, so in this case, like this is a hint for us that the initial value is going to be 1. Okay, so now you have to write this very carefully, this x2. Remember to write wherever you have xn, you write that value inside the brackets. Okay, now let's see this. What is this going to be? Let's write that quickly in our calculators. So for this x3, you will go back to this. This is what you have to write in your calculator. You will write here answer. You'll change this 1 with the answer and you will let it be like this. Okay. So I have 1.5560. Then I go for x4. I only have to press the equal button now. This is 2. You see the values are switching between and beyond this uh, alpha's range. 2.1544 and x5 1.7926. Okay, this is just pressing the, now you see that the values are going to be between this interval 9907. Just pressing the equal button here. 1.8758, 1.9403, 1.9034, 1.9243, 1.9124. Oh, it's a bad question.
सर ये x19 पे जाके कन्वर्ज होता है
1.9192. Okay, 1.9153. 1.9175. Chalo now, this 91 is same now. 1.9175. 1.9163. 1.9170. 0.9166. 1.9168. 1.9167. Yeah, so this is 1.9167. Let me just do one more. Yeah, so this has now converged to. So finally, putting the dots here, our x is 1.92. So this is here, this iteration ends.